All right, so this problem says, construct a window in the shape of a semicircle over a rectangle. If the distance around the outside of the window is 12 feet, what dimensions would result in the rectangle having the largest possible area? So I had to think about the shape for a second, but the shape is going to be a rectangle with a semicircle over it. It looks kind of like, to me, it looks like the free throw line of a basketball court. And modeling this is a little bit difficult, but I'm going to think, I know that I'm going to need formulas for circles and rectangles, and I just know that there's always a radius involved in the circle, and so I'm going to start with calling that radius x, okay, which makes this side down here 2x, and I don't know what else I'm going to call this other side. I'm going to call this y, okay, and so if I'm looking at what's my function that I'm trying to optimize, in this case I'm trying to maximize because I want the largest possible area, it's going to be area as a function of x and y. And the first part I need is what is the area of that rectangle. So the rectangle is going to be 2x times y. And then the other part is I'm going to need the semicircle. So the area of the circle is pi r squared. So the area of half of the circle is going to be 1/2 pi r squared. In this case, r is x. So that's cool, but the problem is, like always, I've got two variables. So I need to do something to get rid of one. So I need to use this other information on here that the whole length around the edge is 12 feet. That's going to be my constraint. That's what I'm going to use to get rid of one of those variables. So turning that into equation, I would get 12 is equal to the circumference of the circle is 2 pi r. So in this case, r is x, and it's only a half circle, so it's going to be pi x plus 2y plus 2x. And what I want to do is I want to get y by itself. So I get 2y is equal to 12 minus pi x minus 2x. And I divide everything by 2. And I get y is equal to 6 minus pi over 2x minus x. And just as a little aside, it's possible in a math problem you would see someone factor out an x like this, so that you would end up with 6 minus x times pi over 2 minus 1. These are equivalent. I don't have a preference, but it is important when you go higher up in math to recognize that you might see things in two different ways. So now I have this. I'm going to stick with this one, and I'm going to substitute it in for y there, and I get a new function, area, and now it's a function of just x is going to equal 2x times 6 minus pi over 2 x minus x plus 1/2 pi x squared. And I know I'm just going to plug that into Desmos, but I think it could be helpful to simplify it. So I'm going to distribute this 2x through, and I get 12x minus pi x squared minus 2x squared plus 1/2 pi x squared. And I have terms that I can combine, these two, so I get area as a function of x is equal to 12x minus pi over 2x squared minus 2x squared. And that's the one that I'm going to put into Desmos. And here is where, when I put it into Desmos, it's going to save me some time if I've thought about what the reasonable values x could be are. Since the whole window is 12 feet, x is going to have to be smaller than 12 feet. Actually, if you do some math, you might realize that x can't even be 4 feet. 4 feet would waste more length in the semicircle than you have at in your arsenal. So x is going to be between like 0 and 4. So let's go to a new Desmos page. Area as a function of x is equal to 12x minus pi over 2 x squared minus 2x squared. And let's say x is only going to go between 0 and 4. And let's put that in projector mode. Then the answer I get for this one is x is going to equal 1.68. And the area is going to equal 10.082. X is measured in feet, and so the area is going to be measured in square feet.